opportunity here to speak today. I really enjoyed Mike's talk. Mike was talking about vaccines. So while it's very interesting to hear about new research, we have to also talk about what we're doing in practice now on the road to prevent future crashes and injuries to the road users. So my talk is about risk rating the roadside. And what that means is that the practical steps that we use to tap into these single vehicle collision descriptions or run off the road type collisions, and what they can tell us about roadside hazards and their contribution to estimating risk as part of the road safety inspection program that we're running in Ireland. It's currently in hiatus because of COVID-19, but we hope to pick up soon when the travel restrictions are over. So I borrowed this graphic from a CEDAR. CEDAR is the Conference of European Road Directorates, and they produced a document in 2013 that I think Francesca worked on called Forgiving Roadside Design Guide. And it shows a cross-section of a typical legacy road, so a road that has some design, but not any modern kind of design standard. And they talked about here the most effective roadside improvement can be accomplished by providing an obstacle-free area. So we want to remove things like timber post and rail fences and stone walls. And the clear zone is composed of different areas. The recovery zone that may include a hard shoulder, but in this case it's just a grass verge, and a limited severity zone. And again, this is an ambitious thing here. Objects that cannot be eliminated should be relocated outside the clear zone. So it's very easy to say that. In practice, it's very hard to do. And again, CEDAR, we're looking at these forgiving roadside the design guides because there was a new EU directive, RISM, the European Directive on Road Infrastructure Safety Management, that required all European road authorities to do proactive road safety inspections. So we'll have a look now at the collisions. So what you're looking at here is the number of collisions that were reported on Ireland's roads that involved some injury when there was a single vehicle collision with a stone wall. And then we had a look at the same type of collision, a collision with a stone wall, but we just resulted in property damage only. And so it was about 260 of them. So that gives us a ratio between injury and non-injury collisions of 1 to 3. And we're using this as a proxy for severity or consequence. So when we're trying to establish risk on the road network, we're using severity or the consequence of that collision as part of that equation. So if you look at the consequence or if you look at risk, it's really a product of consequence and likelihood of a collision occurring. So we'll go back to this sketch here, and we've got some hazards on a roadside. What do we know about them by looking back at our crash data? So we can see here that these circles, just remind you, are representing the typical number of material damage collisions, and then the smaller more solid circle is representing the typical number of reported injury collisions. So we can kind of see here that the timber fence, the timber post and rail fencing is as potentially hazardous to the road user as the stone wall over here on the right-hand side, and the steel barrier we have in front of it, is providing some protection, but we've got very little protection here against this particular hazard. And again, just to remind you that this is a very practical kind of way of trying to establish risk by looking at the consequence of these type of single vehicle collisions. And so we're just using these ratios as a proxy kind of measure for the consequence of collisions. So what can we do to improve this situation? Well, we could take out that timber post and rail fence and protect the drainage feature here that has a higher ratio with a steel barrier that again will offer a little bit more protection. And in an ideal world, we'd actually remove these obstacles here. But again, that's not always the most practical thing that a road authority can do. So while if the likelihood of a collision occurring remains unchanged, then the overall risk can be reduced by introducing measures to mitigate the consequence of any future collision. So that's the example I was actually trying to show here with these graphics. So going back to the other type of single vehicle collisions, what can we learn about them? So I've got a y-axis here, and towards the top of the y-axis, I've got hazards within the clear zone. So things like stone walls and brick walls and the pillars that are propping up those walls as well. I've just added in some animals here because I didn't know where else to put them. They're certainly not designed into the road environment by the road designer. And towards the bottom of this y-axis, I'll show you soon some of the elements that the designer has more influence over. And again, over towards the left-hand corner, you'll actually see that these are things like walls can be described as linear type hazards, where over on the right-hand side, I'm showing the more isolated or discrete hazards that we're picking up from reports from road traffic collisions, and were used to develop these kind of proxy measures for the severity of these types of collisions. So the next one you can actually see is a little bit more what the road designer is interested in: the drainage features, the ditch. There's the timber fence we showed. There's the big item for us to worry about. So for every material damage collision with a tree, we know that there's going to be an injury collision with the same type of actually feature. And so these are not probabilities, they're just ratios, because probability is obviously about having an equal chance of some event occurring. And in this case, you have small trees and big trees. But you can see down here, we're looking at the road verge embankment collisions with the embankment or within a cutting. And you can also see here collisions with parked vehicles. So the road designer or the road authority is involved in putting those features into the road environment. And you can see there's quite a lot of them. Most of them, thankfully, are to do with property damage only collisions. And again, that's probably because of the reduced speed limit within urban areas where you find this type of actually parking. So the last one here now is looking at really engineered parts of the road. So we're looking at concrete barriers. So the ratio is 1:6. So for every one injury collision with a concrete barrier, there's 6 reported property damage only collisions. And you can see here that the wire rope barrier is often most great protection here, a ratio of 1:12. And again, the color doesn't really mean anything. It's just different types of single vehicle collisions or run off the road collisions. So obviously, this is just a quick run through of the kind of practical work that we're involved with here in Ireland on doing our road safety inspections. But just to let you know that we've documented all this work, and we've put it into a paper, and we've submitted it for the 6th International Symposium on Highway Geometric Design. And that's rescheduled for later this year, June 2021. So hopefully we'll be able to present more information about the work we've been doing there. And again, just very quickly to show you, we talk about the background all the way back to a CEDAR project called PRACT that Francesca was very involved with. And you can see down the bottom here some very similar looking charts that I've just shared with you. I'm going to finish up now and talking about this funny looking blue chart over here. It's called a Slanky Chart. And a Slanky Chart is a type of flow chart. And what it's actually showing is the costs of, if we were to mitigate all of the risks that we've identified post the completion of a road safety inspection. And this particular chart is describing about 3,000 items that we identified and risk rated on the motorway network. And if we actually added up all of the costs associated with mitigating those risks, it comes out to be about 26 million. And those costs then split into the different risk levels. So level 3 is the lowest level risk. So thankfully, most of our risks that we're picking up are very low level. And we've got a few of the very high level, level 1 type risks. And then we can actually see those costs splitting up for the particular road element. So all those items that we picked up as we were driving and surveying the main line, or the side road, or the motorway ramp, or we even actually drove and surveyed the overbridge sections. And then finally, we're looking at about 1,000 kilometers of managed motorway network, and they're managed by 5 different consortiums who are doing the basic day-to-day maintenance for us. And you can see here, while we don't have 26 million to fix everything, we can actually certainly direct some funding towards these high-level risks. And we can see most of them are actually occurring in this section here of the motorway network, section 2, and section 3 also could do with some additional funding. Again, this is a very complicated looking chart, but I like using it because collisions, road traffic collisions are complicated, and sometimes I think we might oversimplify things. And my last slide here, I think I'm finishing just about on time, is that, again, Mike used a quote, and so I also like using quotes. So these road safety inspections, another way of thinking about them is that knowing where things are and why is essential to rational decision making. Thank you very much.